So here's another fun theorem that provides us with a shortcut when exploring the relationship between a set of vectors, or between the vectors in a set. So this theorem says that if a set of vectors v sub 1 through v sub p in Rn contains a zero vector, then the set is automatically linearly dependent. So if a set of vectors contains a zero vector, we can automatically state that that set is linearly dependent. This is an awesome shortcut, so let's prove this theorem so that we can take advantage of it. So let's suppose that the index set of vectors v sub 1 through v sub p in Rn contains the zero vector. So in other words, this is saying that there exists some vector v sub k in the set that equals the zero vector. So this is such that k must be greater than or equal to 1, less than or equal to p. Okay, well, since we know that the homogeneous equation, our matrix equation, is equivalent to the vector equation, so since this is equivalent to saying that x sub 1 times vector v sub 1 plus x sub 2 times vector v sub 2 plus la la la, all the way up somewhere in this vector equation there exists an x sub k times vector v sub k plus all the way to that last term x sub p times vector v sub p is equal to the zero vector. So since we know these two are equivalent, let's see what happens when we plug in our zero vector for for v sub k. So we can say that this is equivalent to saying that x sub 1 times vector v sub 1 plus all the way, and then we have that x sub k times the zero vector plus all the way up to x sub p times vector v sub p equals the zero vector. And don't forget that this is such that x sub 1 all the way to x sub p are the weights. So, then this allows us to make the following statement. Well then, if we have 0 times vector v sub 1 plus 0 times vector v sub 2 plus la la la, and then we still have that x sub k times 0 vector plus all the way up to 0 times vector v sub p equals the 0 vector, and this is such that x sub k could be any scalar our little hearts desire, still satisfies the vector equation. And this still satisfies the vector equation because anything times the zero vector is going to be 0. So therefore, since any x sub k satisfies the vector equation, this lets us know that the corresponding homogeneous equation has infinitely many non-trivial solutions. Or we can simply say, has a non-trivial solution. And this is because we can choose any value we want for x sub k, and this equation is still satisfied. So there's infinitely many possible solutions, and so, therefore, by definition, this index set of vectors v sub 1 through v sub p that contains a zero vector is linearly dependent by definition. Woohoo! Oops, we did it! So if a set of vectors contains the zero vector, as we have indicated here, then there's going to be infinitely many solutions that satisfy our vector equation. And so therefore, by definition, if your homogeneous equation has a non-trivial solution, the set of vectors is linearly dependent.